I've made this short video to explain a little more about reflection and refraction. We know that light travels in straight lines, and I'm sure that all of you guys have noticed that when light hits a mirror, it is reflected. I have a diagram here showing how this occurs. So here you have an incident ray of light and a reflected ray of light. This dotted line here is the normal line, which is perpendicular to the surface of the mirror. What you can see in this diagram is that the angle of incidence, or the angle between the normal line and the incident ray, is the same as the angle of reflection, or the angle between the normal line and the reflected ray. So in reflection, the angle of incidence is equal to the angle of reflection. This diagram is showing a kind of reflection called specular reflection. This happens when you've got a smooth reflective surface. All of the reflected rays are going in the same direction. But what about when you have a surface that isn't smooth? In this case, light is reflected in many different directions, so you don't see a clear reflection. This is called diffuse scattering or diffuse reflection. The angle of incidence is still the same as the angle of reflection for each individual light ray, but the normal line is different for each of these rays, so the rays are reflected in many different directions. This is ultimately why you don't see a reflection of yourself in rough surfaces. You can observe that the angle of incidence is the same as the angle of reflection here. When I shine a light at a mirror from different angles, the angle of incidence is always the same as the angle of reflection. So what about refraction? Refraction occurs when light rays move from one medium to another medium with a different density. Remember, a medium is what the wave travels through, so this could be something like air, water, or glass for light waves. When a light wave moves from one medium to another, its speed changes. This causes the light ray to change directions. This is called refraction. An example of this can be seen when an incident ray of light crosses the boundary between air and water. The diagram here shows an incident ray, a refracted ray, and a normal line which is perpendicular to the boundary between the air and the water. The angle of incidence is the angle between the incident ray and the normal line, while the angle of refraction is the angle between the refracted ray and the normal line. You can see that the angle of refraction is different from the angle of incidence because light travels at a different speed in water than in air, so the light ray has changed directions. When the ray re-enters its original medium, it is again going to go in the same direction as the original incident ray. The direction in which the light is refracted is different for different substances. When the light rays enter a denser substance, the light speed slows down, and the angle of refraction is smaller than the angle of incidence. This means that the refracted ray bends towards the normal line. This happens, for example, when a light wave crosses the boundary from air to water. When light rays enter a less dense substance, the light speed gets faster and the angle of refraction is larger than the angle of incidence. This means that the refracted ray bends away from the normal line. This happens, for example, when a light wave crosses from water to air. An example of refraction can be seen when you put a pencil in water. You see that the pencil looks like it's broken or like it's bending. This is because of refraction. The light moves at different speeds in these two media. The light moves faster in air than in water, so the light rays bend when they cross the boundary between the air and the water. In this video, we've looked in a little more detail at reflection and refraction. Thank you all for listening.